here we go. Here, is it possible to get y by itself? No, because one's in a sign, one is not. There's no way you're going to isolate y, right? So you have to use implicit differentiation. No other choice. But usually it's easier anyway. Notice on this last one, that was a pretty quick derivative, right? That would have been the chain rule. Would have been fine, but this was quicker, right? Anyway, going back here, so what's the derivative here? 2y prime. So the derivative is just 2, but you multiply by your y prime, equals 2x
plus y prime cosine.
Exactly. And that's really how we should write it. Because when you take the derivative, you get cosine y, but it's better multiplied by y prime. Most people will write it in front so it's not mistaken to be actually in the cosine. Okay. So now I need to get all my y primes on one side, everything else on the other. So let's subtract this term from both sides. Everything with a y prime on one, everything without on the other. Now what do? Factor out a y prime. I'm left with 2 minus cosine y. And how do I get y prime by itself? Divide by all that junk. I have 2x over 2 minus cosine y. And you know they're not going to plug back in for y because you can't get y by itself, correct? So this is as good as it's going to get. Do I need to evaluate? Nope, that's it. By the way, some books, I think it's easier to use y prime, but some people, instead of writing this, they'll write 2 dy dx equals 2x plus dy dx cosine y. Because remember, dy dx is the same thing as y prime, correct? I personally think it's shorter just to use y prime. But it's the same thing. Just sinking in.